All right. Hello again, everyone. We have Albert Ali Salah with us today. Albert Hoca is a professor at Utrecht University. I hope I spelled it correct, and also at Boğaziçi University. So, without taking further time, Hocam, I am really interested in what you will be presenting today. So, please, the floor is yours, Hocam.
Thank you very much. Thank you very much for inviting me, and I'm also amazed that so many people have been gathered here on a Sunday. Thank you very much for coming. I hope you will find it fruitful. I will talk a little bit about data collaboratives and big data for social good, so that will connect to, I think, what the questions we're asking after the last presentation by Mary Hoca. And indeed, I'm leading the group of social and effective computing at Utrecht University, but I'm still an adjunct professor at Boğaziçi University, where we held just a few weeks ago a workshop on using mobile phone information for migration research. So I will tell a little bit about that in my talk as well, what we do in the Hummingbird Project. Broadly conceived, my area is computer analysis of human behavior, and that's an area where a lot of the questions that you may have pertaining to the social impact of artificial intelligence come into focus, because it's a very broadly conceived notion. You know, computers looking at human behavior, human behavior is very rich. You can think of it as that way, perhaps. You start the computer system starts by sensing the human behavior and then does some analysis on it, and then you have a bunch of applications that will use the results of human behavior analysis. And if we look into these boxes, you can sense the real-world behavior of humans with cameras, microphones, mobile phones, and Internet of Things sensors. For example, a lot of my group is doing work on individual behavior analysis in emotional situations. So when you are, for example, talking to your doctor, we look at your face, we analyze your voice, and we try to understand your emotions, right? So this is more the real world behavior, but but you also have digital world behavior, the digital breadcrumbs you leave behind when you browse the internet, when you play games, when you play online games, for example, and when you're on social media. And that behavior is also analyzed with very similar approaches. So, and the approaches can be theory-driven. Obviously, psychology, cognitive science, and sociology have many theories about human behavior at different resolutions. But it can also be data-driven, right? So you can go on social media, collect a lot of data, and then ask yourself, what are the patterns? What are the regularities? Can I use machine learning to derive those patterns and try to understand or try to link the social media data to some aspect of human behavior? And then we have a bunch of applications, starting with recommender systems, for example, or big engines like YouTube, Facebook, Google. These are all based on analysis of people's queries, right? So they have tons of content. They try to find, given a query, which content matches this query best. And then they analyze your clicking behavior. So I show you 10 results. Which of them do you click? That's also behavior analysis. But there are also a lot of other applications in security, surveillance, healthcare, robotic, entertainment, ambient intelligence, and public good lately. So that part I will focus on in this talk. Our group works on 3 different resolutions of human behavior analysis. We look at individual behaviors by doing facial expression analysis, speech and action recognition, mental health, sentiment, personality analysis, deception detection, and all kinds of things. Then we look at dyadic and group behaviors, where we investigate turn-taking, mimicry, rapport between the people, especially between a psychotherapist and and a patient. For example, we call this working alliance. We look at nonverbal signals. We look at games and playful interactions, and also to child-parent interactions. At Utrecht University, there is a very big group of studies called the youth cohort, where 3,000 families are tracked from pregnancy to adolescence. So there's a lot of data about child development, and we try to analyze some of this data with our approaches. But at the largest scale, so this is like one person, a few people, but then at the largest scale, you do computational social science, you analyze thousands or maybe millions of people. And at that scale, the use case that we focus on in my group is migration and mobility. There are implications, obviously, in urban computing, epidemics models, and developing social indicators. And we can discuss them a little bit later as well. So this kind of work has two sets of challenges. One of them is obviously a technical challenge. We ask the question, can we automatically interpret and predict complex human behavior with AI techniques? And this is also a broad question, right? You have to ask this question specifically for every little domain that you're going to address. For example, if you want to understand whether when Turkey opens the borders with Greece and Bulgaria, will Syrian refugees flock to the borders and cross over into Europe? Okay, here's a question that you ask. You can actually observe their behavior if you have, for example, sensors that can record their movements, right? So, and then you can perhaps build an AI model and use it for prediction. But there are also humanity challenges in this problem, because you develop an artificial intelligence-based solution and people deploy that solution, they start using it, and that solution starts changing people's lives. Right? So what are the social implications and ethical considerations in the deployment and widespread use of these tools? Means, suppose you create an algorithm for selecting tweets that will appeal to people that are using Twitter, right? These are, let's say, a recommender system. Now, if you select select tweets that are very similar to what a person's world of view is, then that person will only see news or opinions that are very similar to their own position. And that creates echo chambers, that creates filter bubbles. So over long periods of usage and over millions and millions of people using these systems, this algorithm may deepen the social chasms in the society. So people who subscribe to a particular political point of view will find themselves more entrenched in that political view, which can have very bad effects on the society. Maybe the widespread use of social media is one of the reasons while of everywhere in the world, the right-wing parties are gaining strength, because they promote these kind of extremist entrenched worldviews. So then we need to ask ourselves, if we develop some artificial intelligence technique, what are the consequences of these techniques, right? Especially for every individual algorithm that we develop or system that we develop, we are in the best position to assess the damage that it can cause to the society. So I'm talking about the damage, but of course, the impact is not necessarily always bad. We can also try to do some good in the world. And for that, the United Nations Sustainable Development Goals provides a very strong and very nice framework to structure the social good we try to achieve, to have a better world, you know. I'm sure you're familiar with this framework. But let me just show you a McKinsey Global Institute report, which analyzed which artificial intelligence solutions address which of these sustainable development goals. And then you will see that there are, this was in 2019, there were about 160 case studies addressing different parts of the SDGs. Our own group's research focuses on health, especially mental wellness. So we address this with affective computing, and about migration crisis, where we try to address this with social computing, so at a larger scale. And I'm going to focus on this bit in this talk. This is a short list prepared by Anna Bethke from Intel about ingredients for social good. So if you want to do AI for social good, what do you need actually? Well, of course, you start from a problem to solve, and the narrower the problem, the more chances that you are going to have an impact, because broader problems will probably require very complex solutions and will require coordinated effort of many, many people. But you start from a problem to solve. For example, helping the Syrian refugees in Turkey. There are still over 3 million refugees, well, actually over 5 million refugees if we count the Afghan refugees as well, and the Ukrainians. Let's say you start from a problem to solve, then you partner up with people who have different insights into this problem. So for example, if I'm a computer scientist, I may not have a very good understanding of what the refugee problems are. So I partner up with demographers, with migration scholars, with policymakers, and with IGOs and NGOs that work with refugees. Then you collect the data with features that represent the problem, and you try to do this in an ethical and privacy sensitive way. And I'm going to show you how, in our particular case, we did that. Then you get some computing power. Of course, you're going to be crunching some data to help them. You develop your algorithms, and then you test whether the system works the way it should, right? You want to test different scenarios. You want to also see, you want to take a Popperian attitude, and you want to try to see the scenarios in which your system will fail miserably. Okay, so you create a system to look at refugee movements over the country. Then you ask yourself, when will I fail? Where will I fail? And what will be the consequences? Then, you know, of course, if you can manage, you go one more step and you try to deploy the system in the real world, and then constantly monitor it for correct functioning. You can never deploy an AI system and just leave it be. You have to always be careful and understand, continue to monitor it to see what is going on with it. Now, data collaboratives are a particular way of working on social good. That's a cooperation between private and public sectors in the field of data sharing and statistics. And the reason we have data collaboratives is that private companies collect tons of data about you. Okay, your mobile phone company knows where you live, knows where you work, where you go for entertainment. It knows whether you're a Muslim and go to a particular mosque on a Friday, or whether you're Jewish and go to a particular synagogue on Saturday mornings, or to a church on a Sunday mass, right? Your phone company knows so much about you that this information actually could have been extremely interesting to people who are creating policies. So an interesting example is that we started collaborating with IOM, the International Organization for Migration, in Mongolia in November. And we gave them a bunch of a series of lectures and tutorials on using mobile phone data for addressing data gaps. Now, Mongolia is a big country, it's a huge country, but there is only 3 million citizens going around. And a lot of it is a nomadic populations. And these people come to the cities for the winter because out there it's very, it's cold, the resources are scarce, but there is no good way of seeing who is where at any given time. And the government wants to know this because they want to optimize the resources. Because if you know that so and so many people will come to a particular city, then you can allocate resources. You can make room for living, education, security, healthcare, and all kinds of that. So what you can do is you can team up with the mobile phone company, which knows where people are, obviously, because it knows at all times where people's phones are. And then you can build models, predictive models or explanatory models to observe the human mobility over a country. And this is the kind of analysis that I'm going to talk about in this talk. But there are many sources of private data. It's not just the mobile phone companies. You can also have satellite imaging, social media content. You can use wearable and smartwatches. You can use the infrastructure. For example, if you have a railway structure like in the Netherlands, we have a huge railway infrastructure. Every time people use their cards on the trains, the government knows, or the railway company knows, but it's a government company. So they know where people are going, where they are coming from, where they're going, how much time they're spending in these cities, and when they're coming back. So they can optimize a lot of services based on this information. You can also actually see this information. If you go on their website, you will have some interactive visualizations allowing you to use this data as well. Now, mobile phones, of course, became very important when the COVID pandemic started, because people realized that there can be many uses of mobile phones to control and help with the pandemic. So in this paper, we kind of try to group the uses of mobile phones for a pandemic response, including situation awareness, cause and effect modeling, predictive analysis, and also impact analysis. So for example, if you implement certain lockdown measures in one city, then you can observe the behavior of humans in that city and try to understand how much impact your lockdown policies had on these behaviors. So for example, you can observe whether people are gathering less in public places together or whether they have problems reaching resources. Now, mobile phone data can be used in different ways. You can have an application which will collect data for you, and people who are installing the application will say yes to a customer agreement granting you data collection rights, right? The problem with this approach is that you will only get data from people who have this application on their phones. And then there can be some biases involved with that, okay? But if this is a very common application, it's a very used, let's say if it's a governmental application like an e-Devlet application, for example, Hayat Evesar application, for example, you say, okay, here is my COVID application. I want all my citizens to use this application. Then this is no longer an issue. You collect data from all your citizens practically, or almost all of your citizens. Can you guess what portion of the citizens you will be missing if you do that? If you ask them to install Hayat Evesar, and let's say you make all kinds of services like using trains and metros only through that application. Let me open the chat and see whether elderly people, yes, but okay. Don't let my grandmother see this response. She will be very angry with you. She's 95 and she has a very, she's very tech savvy, right? But some elderly will be left out, yes. But maybe something else? Okay, so Gamze says no phone, no mobile users, but who are these no mobile users? The ones who cannot access smartphones or afford, yes, that's correct. But that's a very small percentage. Even the very poor people usually prioritize phones, maybe not smartphones, maybe not expensive ones, but you can purchase a phone quite cheaply as well. And it's very important if you're looking for jobs, for example, to have a phone, because a lot of services are only accessible through phones. So the coverage is pretty high, actually. But there is one important group who doesn't have access to phones? No, not with people with disabilities. Well, maybe some severe ones, but they would probably find a way to use a phone in a... Yes, Shema has the correct answer. You cannot own a phone line if you are below the age of, I think, 16. So even if you are, let's say, 14 years old and using a phone, maybe that phone is not registered to your name, but it's registered to your parents' name. But I doubt that people, let's say, smaller than 10 years old will use a phone. So if you want to do an analysis of mobility, you know, and you want to look at people's usage of primary schools, then you may not see them on the phone data. Anti-vaccine people. Yeah. You mean, so these are the Luddites, right? These are against all kinds of technologies. It's actually it was a group in the US. The name comes from there. Okay, but so, okay, that's one way, we said, using an application on the phone. But you can also have the application interact with a system. So for example, let's say you have a supermarket application. Every time you go to a supermarket, it has a handshake with the infrastructure in the supermarket. Then that's also a possible way of getting data. Another way is using mobile call detail records or extended data records. And that's some information that is collected by your mobile phone company. So instead of getting data from people directly, you can get the data from the mobile phone company. And I'm going to show you how this can be done. But once this mobile phone data become interesting for human behavior, and this was a study done in MIT by Alex Pentland and his group in 2004 and 5, it was called reality mining. What they did was they distributed 100 phones to people at MIT, students and faculty, and they collected data for a year, and then they tried to see what kind of patterns they can discover with this data. And the results were very interesting because just by looking at phone behavior, and a very simple behavior, right? When is it on? When is it off? And is it on? Is it at home or is it at work? You can tell whether it's a student or a faculty, the owner, whether you're talking about an economics student or an engineering student, whether it's a first-year student or a senior student. You could all distinguish these patterns quite reliably because people have actually a lot of regularity in their lives, and mobile phone usage reflects this regularity. So from that moment onwards, there were a bunch of databases available where you can analyze phone data. Mobile phone call detail records, or called data records, CDR, we call them in short, they are a different kind of beast. So the advantage of CDR is it's very comprehensive. So if you work with a telco, let's say like Turkcell in Turkey, you have access to 35% of the people in all the country, which is huge, right? I mean, it's basically millions and millions of people. And you can get insights which are much more beyond, let's say, survey studies, which are typically done on a couple of thousand people at most. If you do your job properly, then you don't need explicit consents. Why? Because every time you purchase a phone line in Turkey, you sign a contract with the telco, and that contract tells you that this data will be processed anonymously and in an aggregated fashion for research purposes. So you give consent when you get your phone line. But the key here is that it's processed anonymously. So nobody will be able to track you. Well, actually, the telco doesn't process it anonymously because they also want to sell you things. So they customize their campaigns according to that. But if the data will be processed for research purposes, then that has to be done in an anonymous fashion. It's also quite granular, right? Because we can see people's mobility at the base station level. Every time you make a phone call, I know which base station you are in, or roughly where you are, let's say, and that can be quite granular in big cities. The disadvantages are that this type of data is very, very difficult to obtain. Basically, you need to convince the legal department of a telecom operator like Turkcell or Türk Telekom to share with you this data. And they have very little incentives to do that, right? So this is difficult. It is sensitive. If you share it without taking precautions, it can lead to a massive surveillance scenario. So during COVID times, the health ministry in a country that I will not name here because this is going to be made public, but you can guess which country it is, went to the 3 telcos in the country and asked them to dump their CDR on the health ministry records. And they wanted to link the people's IDs with their ID numbers so that they can link the mobile phone data with the health data. And that's incredibly sensitive. Can you give me one example of a very bad use case if the government has access to complete CDR with all kinds of people's data? I just opened the chat. So just write suppressing social movements. Okay, Mehmet Akif is giving a good example. So for example, let's say there is a social movement and people are amassing in Taksim Square and shouting slogans and they're walking. Now the government actually can look at the CDR and learn from that exactly who has been in Taksim Square at that moment. So they can create a list of people joining that protest, for example, or an opposition rally. Okay, maybe there is a party that the government is opposed very strongly, and then all the rallies of this party, you can just read it from the CDR who is joining these protests or party rallies. So that means you have to be very careful in processing this data. I have a bunch of questions at the end to discuss with you a little bit more about these things. So this is how the data will look like. You will have a timestamp, and then you will have 2 telephone numbers. The first phone is calling the second phone, from which geographical area, basically from which base station to which base station, and then what is the duration of the call. You need the duration sometimes because some of the phone lines which are calling people will be actually robots. They won't be actual people. They will be services connected to phone lines, and they will be making 1,000 phone calls a day, each of them similar duration or limited duration. And then you can use this meta information to filter them out. You can also have similar records for all the SMS messages sent, right? So from this kind of data, you can look at call durations, numbers of events, lapse between events and reciprocated events. So for a single person, you can use, for example, the number of events and the lapse between events to tell whether that person has a good social life or not. And that can be very interesting if you're looking at social integration of refugees or migrants, for example. You can also look at the social network, in and out degree, unique calls per day, unique SMS messages per day. This is less done now because we figured out that this is actually very critical data, where if you start unraveling, like if you discover one person's identity in the social network, the rest becomes pretty easy to uncover. So usually we don't do social network analysis on CDR data anymore. But you can get mobility indicators like radius of gyration, travel distance, rate of popular antennas, regularity of popular antennas. And these can be linked to a number of indicators, right? So for example, by looking at how much a person is able to travel, you can say something about how wealthy that person is. Or during COVID, this was exactly the opposite. The rich people were able to stay home and isolate themselves, but the poor people had to go out and work because they did not have the resources. They had to work every day in order to survive, so they could not stick to the curfews. And this can be seen in the mobile phone data as well. Large-scale CDR datasets are very rare. The first one which was made available was in 2011, Orange Telecom in Ivory Coast, which was a monopoly, which had the 95% of the phone lines in the country were Orange Telecom. They collected a data set of 5 million people, collected over 1 year, and they made this available to, as a collaborative between the government and the telco. They made a data challenge. They said, okay, here is a data from 5 million people, use it to suggest some improvements in the country. And these could be on anything. This could be on transportation, agriculture, health, education, security, anything. Because Ivory Coast was just exiting from a civil war and the country was in ruins and they needed development. And this was a very successful project. I will show you what kind of data they have made available in a minute. But a couple of years later, they also did another project in Senegal. And then there were 2 projects, one by Telecom Italia in Italy and Telefonica in London. And then between 2016 and 19, I coordinated the Data for Refugees Challenge in Turkey. That was a collaboration between Boğaziçi University, Türk Telekom, and TÜBİTAK, and also supported by IOM, UNHCR, and UNICEF, among other things, among other institutions. And the aim was to help the Syrian refugees in Turkey. So how can we help the policymakers in particular to develop good policies for the Syrian refugees? At the moment, we have at Utrecht University a project called Hummingbird. That's a European Union project. And that the purpose is to use big data to study migration, not just migration from Turkey into Europe, but in the mobile phone work package, we collaborate with Turkcell and we study migration via mobile phone CDR data. So let me show you a little bit about, let me speed up a little bit as well. The Data for Development Challenge was a very nice challenge, like sharing this very sensitive data with a lot of groups. So 166 research groups received the data, because the biggest challenge is to get the data out of the telco. And if you have a good legal agreement, then you can make it available to other people. And then many people can look at the data from their own perspective, and then you can enable multifaceted analysis. So the kind of data that they shared was antenna to antenna traffic on an hourly basis. So I tell you, for example, at this hour, 55 calls are made from Taksim Square to, let's say, Kızılay in Ankara. Okay, so this kind of data, where of course there are many people in this area, so you cannot use this kind of data to track people. There's no identity linked. Then you have individual trajectories for 50,000 customers for 2-week time windows with antenna location information. So you take a customer for 2 weeks, you give all the antennas for every phone call, but of course you don't give the actual phone number, you just anonymize it, you replace it with a random number, and then you return the customer to the bag and draw another 50,000 customers for the next 2-week period, so that one person is not tracked for longer periods of time. Then you have 500,000 customers tracked over the entire observation period, but then I tell you that this person is in Kadıköy, for example, and not at which antenna that person is. And that's much coarser. It's not enough to identify people. In the first D4D, a sample communication graph was made available for social network analysis, but this was discontinued. Now, how do you anonymize and aggregate the data? Well, if I tell you that this customer has one phone call at this location at 8:32, another one at 9:15 from this base station, another one at 12:05 here, and another one here, well, every time you make a phone call, we know the base station. That means you're in one of these Voronoi cells, right? I know you are in this cell with high probability, not perfect probability, because if the cell is very crowded, then the next base station may pick up your phone. But I know that you're in this area and I know your phone calls. Now, if I call you 4 times at very specific times, and then probably I can find you in the database. by just looking at the exact phone call times. So one thing you need to do is you need to temporally anonymize this data. So instead of giving me precise time calls, you tell me that this person was in this area between 8 and 9, in this area between 9 and 10. And if the area or the time window is too small, so that only a few people are identified that way, so then you can enlarge them. You can take, for example, 2-hour periods or larger Voronoi cells. Typically, what we do is in the cities, if they are these cells become very small, we join them, we fuse them together to obtain larger scales. In the Data for Refugees challenge, we also provided very similar information. We collected data from 200,000 refugees and 800,000 non-refugee residents over Turkey over 1 year, so the entire year of 2017. We prioritized 5 areas: safety, health, education, unemployment, and social integration. And we asked the challenge participants to submit proposals and then do projects on one of these 5 areas. And then for every area, there was an award given to the best project. Each participant signed a strict agreement. Individually, all the researchers put their names on these confidentiality agreements, and every research team was led by a permanent staff member of an institution. And a short proposal was submitted first with the aims of the project, and we assessed all the proposals. The denied projects, well, projects with obvious commercial interests. So, there were people trying to sell things to refugees, and this data set was interesting for them. They did not get the data. If the project did not have a good technical description, they did not get the data. So we had a bunch of well-meaning projects with who had no idea how to accomplish what they wanted to do. And projects with potentially sensitive topics did not get the data. For example, we had projects from DARPA, referencing a question asked at the end of the last talk, but we also had a project coming with connections to the Turkish Ministry of Defense. Both of them did not get the data. Now, the ethics issues obviously are very important. And let me stop here for a minute and ask you, is there anything that you want to ask about the data collection or the nature of the data? Anything you want to ask here before I start talking about the ethics issues? Just type it in the chat or raise your hand and I'll give you the word. Okay, then let me continue. But if you have a question, put it on the chat. I will be able to see the chat messages. Okay, the first thing you need to understand if you have never worked with ethical analysis is that every time you do ethics, you try to balance the benefits and the potential harm. You can never say, oh, this data is sensitive, let's not do anything with it, it's not ethical, because what you do with it can be quite ethical, actually. In fact, it also, as a data scientist, gives us a responsibility, right? There is a situation, a crisis, and we are in a position to help these people. Not doing something is not ethical. But of course, when you do something about it, you have to be careful not to harm the people that you're trying to help. So the first thing you need to pay attention to is consent. The data sharing must be permitted by the owners of the data. And for mobile phone challenges like this, we're getting the data in an anonymized and aggregated fashion from the telco. So at the moment the data reaches us, it is aggregated and anonymized to such a degree that we cannot identify people in it. Okay, so that's important. And this type of processing is permitted, for example, in Turkey in the communication laws. The second one is protection. you should be able to ensure that no individuals can be identified or tracked with the data. That was, in fact, the first condition UNHCR gave us before joining the project. They said, you have to ensure us that this protection and of course also consent and protection, they were satisfied. The third thing is retention. You have to limit the use of data. You cannot say, okay, I give you the data and you can use it indefinitely. You have to tell when the data lifetime will be over, because who knows what the technology will be able to achieve in 10 years' time. Maybe you will be able to harm the people using the past data. So at the end of the challenge, we had a grace period for publications, and then all participants had to destroy the data. The do no harm principle is something you know from medicine, right? You know, the doctors were told first not to do any harm. There is a modification of this principle in our case. And I'll give you an example. So the idea here is that we look at the project reports and try to see whether the report can in any way harm the refugees. For example, the refugees did not have working permits to work on the third airport construction site in Istanbul. But if you look at the data, you can clearly see that they are working there, okay? The refugee presence is very clearly seen. Also, the Antalya municipality did not allow them to work in the tourism during the tourism season, but you can see that they're working there. Now, obviously, this is illegal work, and I will come to your question in a second, Efe. So you know that this is illegal work, but out of 3.5 million refugees, only 60,000 refugees were given work permits. So illegal work was, it wasn't a secret. Everybody knew that these people were working illegally. Otherwise, how are they going to survive? But if you publish this, okay, and let's say the opposition party picks up on this and says, oh, the government is allowing the Syrian refugees to work on the third airport construction site, those people can lose their jobs. Even if they are illegal jobs, they can still lose them, and they can be harmed by that. So we were careful about not publishing these kind of things. A very similar case is in the migration use case. We can see when people are coming to the coast to, for example, to escape into Greece from Turkey. Now, if we publish this in real time, then the government can actually go there and apprehend these people, right? And then we will be harming those people instead of helping them. Now, Efe is asking, do you think that European Union cookie law affected the privacy concerns? And the cookie law does not apply in this case to this kind of mobile CDR data. Plus, of course, Turkey is not in Europe and it's not a party of the GDPR. So from our perspective, there was no change based on the European laws. However, it is true that most computer analysis of human behavior is more difficult in EU because of stricter legal conditions. In Israel, for example, the government can directly read all the CDR data because it's a country with a lot of terrorist attacks, live bombs and everything. So the security concerns are much, much higher than any other place. And the government has made it a law that the government will be able to track individuals if they need to. So this is something that you have to really go over with the law people. But you have to also be careful about the distinction between ethics and legality. Some things may be legal, but not ethical, okay? For example, in Turkey, if a rector of a university hires directly a person to a department, they have the power, that's legal. But is it ethical, or is it reasonable behavior, commensurate behavior with academic freedoms? That's not the case, right? But sometimes you have cases where people are giving a lot of power and the legality is there, but ethical concerns have to be obeyed in all cases. Okay, I will have a bunch of questions for you at the end about this. Now, data protection by design and default is the principle that tells you the data during collection is anonymized to such a degree that it's impossible to track individuals. And that's an important principle that we followed. Okay, so what did people do with this? They were able to model mobility between cities. That's the obvious use case. But this is, for example, a work by the Migration Research Center in Koç, in Mirekoç. They looked at mobility of seasonal workers. So they knew that refugees will come to work in the hazelnut harvest, but nobody knows where they are coming from, how long will they stay, when will they live when they come. And with the data, this was very easy to observe. So you can use this 2017 data, obviously, to predict what will happen in 2018. And if you know that a lot of people will be coming from Antalya to Ordu, maybe you can, put some bus lines between Antalya and Ordu to help these people. This was a research done by a group in Sabancı and a collaboration between Sabancı and MIT Media Lab. They developed social integration indicators. So they looked at places where refugees and locals came together, and they also looked at the relative ratio of refugee to local calls, and they were able to see which cities have good integration and which cities have bad integration. Another project done in collaboration with Kızılay looked at healthcare. So these red dots you see here are the mobile health centers in Istanbul, and the underlying map shows the number of refugee residents. So you can see that there are mobile health centers for refugees that are installed in areas with almost no refugees, whereas here you have a bunch of areas with a lot of refugees but no health centers. So policymakers can then improve their placement by using this kind of data. You can also use this for modeling epidemics. Measles was an epidemic that was eliminated in Turkey because of good vaccination, but the Syrians were mostly unvaccinated. So you can see how a measles epidemic broken out in different cities will spread out because now you know the mobility of the people and you know the connections between the cities. So you can do simulation studies. You can also see mobility on special days. You can see where people, refugees, are going on, for example, Ramadan or the religious or national feasts. You can observe people's behavior during emergencies. You can also detect anomalous events. So this is the number of calls from a single base station, and you can see that it's like a heartbeat of the city. And then you can see sometimes there is the number of calls from that base station explodes. And this can be a general thing. Maybe, your country is in the World Cup and it's scoring a goal. So you will have this peak in almost all the base stations across the country. Or maybe somebody is just killed on the street, which was the case in this one, I think. This was Ivory Coast data. And then people who see this event start calling each other, and then you have a peak. All the project reports are collected into a book published by Springer. And if you go on my webpage, you will also be able to see the unedited forms of all the project reports in a PDF. Now, I'll skip the FlowMinder and Opal systems. Basically, these are softwares to help you get the data out of the telco in a privacy-aware way. But I'll also skip the policy implications. If you want to learn more about this, this is a new book published by Oxford University Press in the British Academy series. It just came out a few weeks ago. And it includes a bunch of chapters on how to use mobile phone data, social media data, satellite data, financial data, all kinds of event data for studying migration and mobility, and includes the chapter that I just mentioned on ethical and legal concerns. Now, maybe I'll say a few more words about the Hummingbirds project, because this is our collaboration with Turkcell, where we look at refugees in Turkey, Syrian and Afghan, migrants and other internal migration. And the kind of analysis we're doing, we're also combining the mobile phone data with satellite data. And this is, for example, a quite recent view of where the Syrian refugees are over Istanbul, for example. And you will see that there are certain areas that are showing a lot of activity. And then, of course, you have to collaborate with social scientists or go on the field and do qualitative studies to understand what this corresponds to. Now, I'll leave you with a few questions. And these are some of the things that I will ask to you. I'm not going to answer these questions, but maybe you can think about solutions yourself. One of them is datification, which means the governments are now able to harness these technologies like surveillance, face recognition. You have probably seen news about Uyghur Turks in China that are recognized from their faces and then discriminated against. But similar technologies exist in Europe in asylum and border control. You might have heard of Frontex, the company that Europe outsourced its border control. If you haven't, Google it and try to learn a little bit about what Frontex is up to. So then basically the state's perception of reality becomes datafied. That means people are reduced to numbers. But every migrant, every refugee is a human being. So it's very important not to see them as numbers, but as individuals. So one question is, if we use these technologies, will we start seeing people as numbers? Okay, will we be reducing them to numbers? And that's dangerous. That's very bad for people. The second question is, the governments are doing technological experimentation in migration and humanitarian contexts. So you will see a lot of biometric applications in refugee camps, for example. This is born out of some necessity, right? Because most of these people do not have ID cards. So how do you identify them? Or though these cards can be stolen or traded, then you don't know whom to provide help. So if you can replace this biometrics with biometrics, then you can find the people who need help and directly help them. But if you are interested in this question, look for the writing of Petra Molnar, and she's a very vocal person, writes very well, and draws attention to all these problems. This was a news feature in Nature in 2019. Can tracking people through phone call data improve lives? Which also discusses the Data for Refugees project. But there are very clear use cases, especially in the aftermaths of hurricanes or earthquakes or COVID pandemic, where mobile phone call based tracking can really help people. The key is not to make this into an infrastructure which the government can use to introduce mass surveillance in the society. And then, as I said, always you should balance potential good with potential risks. And you have to really try to understand what will be the implications. So this report was written by Vodafone Institute and Datapop Alliance, of which I'm also an advisor, about forging these data collaboratives between public sectors and the governments. So I will take a few questions now, but if you have questions, you can always send me an email. This is my email address and Twitter handle. So I'll stop my screen share so that I can also see you. Oh, no, I don't need to do that. I can see you here. Okay. I will just open the chat window, and now the floor is yours. Thank you very much.
Thank you very much for this interesting and a little scary talk. I mean, it is shocking to see how many data people can access, the companies can access to. I mean, we know it, but when we see it, it always gives me the glimpse. So
Well,
hocam,
Ömer, actually, mobile phone companies have a lot of data about you, but there are other companies that have even more data about you, right? If
that's
you ever open your browser and have a look at the cookies it stores, and those cookies are actually sold, you know, every person's in this talk, you know, we have our cookies sold to hundreds of companies. So that's way more information that we're letting on, actually.
yeah, so I also have a question about that too. So in the social media applications, I believe there are way more and more data than, for example, that are in SMS technology. So do we see any implications of this data in computational social sciences?
Of course. So, for example, Twitter has been used in computational social science quite frequently because it has an API that allows you to collect data with a specific hashtags or keywords. And it used to be some of the data would be geotagged. Now it's less and less. But as people realize the sensitivity of these data sets, Twitter also changed its API more than 10 times over the past few years. So if you go to the Twitter-related chapter in our latest book, then you will see also the historical perspective of how the API changed. But now they made a research API available. So if you're doing research on Twitter data, you can contact them with a project and they will grant you access to more data. Similarly, Facebook has initiatives that help you to observe social computing related information through the Facebook marketing API. Ingmar Weber, who's now in Saarland University in Germany, is doing a lot of research with this. And there's also a chapter in the book about using Microsoft data for this. For skilled migration, LinkedIn data is extremely valuable, right? But if you want to go for unskilled migration, LinkedIn would not be very useful. But for specific use cases, then you have to find the correct social media channel that provides you with the rich data for that.
Thank you, hocam.
Mehmet Akif has a question. I guess the data coming from personalized transportation cards also might cause municipalities to use them for good. What do you think about this kind of data? Yes. So so it depends a little bit on how the infrastructure is created in the country. For example, with my train card, I travel all around in the Netherlands. Whenever I go to a different city, I can use the metro, the bus, even the public bicycles with my train card, with a single card. It's all integrated. But if you're living in Istanbul with your Akbil, you will not be able to use it when you go to Ankara, for example. And you will also not understand that the person is going to Ankara because, you know, if they take a train or a plane, that will not be registered on the Akbil. You can only assume that they're leaving the city if their destination is the airport, for example, or the train station, right? But then you will not know where they're going. So what can you do with the transportation data? Well, you can actually see if you go on the transportation company's website. Well, no, on the National Statistical Institute website in the Netherlands, they will show you a visualization of the transportation data. And you can see, for example, how many people live in Utrecht and work in Amsterdam, because you can see every day at what hour, how many people are traveling from Utrecht to Amsterdam and coming back. This will be a portion of the people. You will not see the people who take their cars to do this. But a lot of people in the Netherlands use the trains. It's cheaper and parking is very expensive in Amsterdam. So you will, if you have a rough notion of what is the percentage of people using the trains, then you will get a very good understanding of these things. So yes, actually it's pretty useful, I think, for the municipalities. And in urban computing, municipalities collaborate with mobile phone operators to improve services. Okay, so for example, let's say a part of the city is now used as a as an entertainment area, let's say pubs and clubs are opening there and people are going there and staying late, then the municipality can see this and then decide to put a night bus service for that location to simplify the people's going there. But of course, this is policy, right? And a lot of different things go into policy. It's not just data, but you have to also understand what's going on with the people there. Any other questions? Don't be shy. Okay, then maybe we can stop here.
Hocam, thank you so much again for this presentation. I am stopping the recording right now.